to talk about some different kinds of reactions. We mentioned combustion at the beginning of the chapter. Combustion reactions are characterized by the reaction of a substance with oxygen, and then you're going to get one or more oxygen-containing compounds as a product. It often includes water as one of the products. And combustion reactions emit heat. So if our compound that we're burning only contains carbon and hydrogen, or carbon, hydrogen, and oxygen, the products of complete combustion are always going to be the same. All of the carbon goes into CO2, and all of the hydrogen goes into H2O. And if there's oxygen here, some of that oxygen will end up in one of these along with this oxygen. So this is something that you are expected to remember. For compounds containing carbon, hydrogen, and oxygen, the products of complete combustion are always carbon dioxide and water. CO2 and water. So we should be able to do something like this, write a balanced equation for the complete combustion of liquid C2H5OH. So they're giving us a reactant, C2H5OH, and they're telling us it's a liquid, and they're saying it's combusting, it's burning. What's the other reactant then? Oxygen, because you need oxygen for anything to burn. And what are the products? CO2 and water, H2O. Well, CO2 is normally a gas, right? So that's not a problem. At room temperature, H2O is a liquid. But is this at room temperature? No, we're burning something. It's hot. What happens to water when it gets really hot? It becomes a gas, right? So this is going to be in the gas state. I'm not going to try to trick you on that, but you should be able to remember that. So there's our skeletal equation, and then we have to balance. So start with the carbons. 2 carbons. So over here, if I put a 2 in front of CO2, that'll give me 2 carbons. Hydrogens, need to be a little bit careful here. There's 5 of them here, plus 1. The reason that this is written as OH at the end is because this is an alcohol. And alcohols have that OH functional group. I don't expect you to remember that, but that's just why it's written funny. So here's a total of 6 hydrogens. So how many water molecules do I need? I need 3, because each of them has 2 hydrogens. So carbon and hydrogen are balanced, and now we have to figure out the oxygens. So I'm going to look over here and see what I've got. We've got 2 times 2 is 4 oxygens there, and 3 times 1 is 3 oxygens here. And that's going to be 7. Over here, I've got room for a coefficient times 2, but then I also have this guy.
3.
So I need this side to also equal 7. I've got 3 if this is a 1. But I can put a coefficient in here to balance the oxygen and not mess up anything else. So this is going to stay a 1. I need the total here to be 6, right? 6 plus 1 is 7. So that needs to be a 3. Any questions? I remember as a student thinking, how the heck am I supposed to remember these chemical reactions? Well, now that I understand it a little better, I see that there's these patterns, right? And so combustion, carbon dioxide, and water. If if things like octane burn cleanly, if they are pure and burn cleanly, they only make carbon dioxide and water. There is already carbon dioxide in the air. There is already water in the air. Those aren't really pollutants, are they? It's not like the NO2 that's going to make nitric acid, right, and rain down on the trees and cause their leaves to fall off. So carbon dioxide and water, two, pretty innocuous things. So that was combustion. Alkali metals. These are the group 1 metals, and they are very reactive. When they react with nonmetals, the reaction is vigorous, to say the least. This is an illustration, or a photograph of sodium metal reacting with chlorine gas. And it's reacting so violently that it's giving off light and probably heat as well. So a metal can react with a halogen. X is often used to represent one of the halogens. And then you're going to get a metal halide as your product. Here, two sodiums plus a chlorine molecule is going to give us 2 NaCl. And this product isn't really a mystery. What is the formula for the compound formed between sodium and chlorine? Sodium is a metal, chlorine is a nonmetal. That's an ionic compound. So we know that sodium makes a +1 ion, and that chloride makes a -1 ion. And you shove them together, and you get this, NaCl. So if these two things are reacting, you're going to make something that's got both in them. And for these, the charges are going to tell you what the formula is going to be. And then you have to balance the equation, right? Because there's 2 chlorines here. So I need 2 NaCl's, and that makes me need 2 Na's. Okay? So it seems hard, but it's really just write the formula that forms between the metal and the nonmetal based on the charges from the periodic table, and then balance the equation. It is doable. I forgot this part. The reactivity increases as you go down. So, sodium is vigorous, potassium is more vigorous, rubidium is even more. And here we have photographs of them reacting with water. So lithium, sodium, and potassium. When these metals react with water, they're going to give off hydrogen gas. Hydrogen gas is flammable. Right? Here we just see the bubbles of the hydrogen gas being formed, but here there's enough heat that the hydrogen gas ignites. And here it's igniting and shooting all over the place like fireworks. The halogens are among the most reactive nonmetals. So we just talked about how the alkali metals react with the halogens to form metal halides. Well, the halides can react with other metals also. And again, to predict this product, you're going to find out, well, what's the charge on that metal ion? Write the formula, and then balance the equation. Halogens can also react with hydrogen. When they react with hydrogen, they make hydrogen halides. These are basically binary gases that haven't been dissolved in water yet. You can also get reactions between halogens, but we're not going to talk about those. These are vials containing halogens. So chlorine is a gas. It has kind of a yellowish-green color. Bromine is a liquid at room temperature, but you see there's also some gas here because it's evaporating. So it's a dark brown. And then iodine is really kind of funky. It's a solid at room temperature, but it sublimes very easily. And so you see it subliming just like carbon dioxide, dry ice does. and forming this purple gas. It's very pretty. Okay, write a balanced chemical equation for each reaction. The reaction between aluminum, metal, and chlorine gas. So, this seems unreasonable. Oh, yeah, I was getting rid of a smudge. That's weird. But let's just think it out. So, what are my reactants? Aluminum and chlorine gas. So, I have aluminum, Al. What state is aluminum at room temperature? Solid. You may know that from experience, or you can look on the periodic table, it's black, so it's a solid. And what's the formula for chlorine? Cl2, because that's one of those diatomic elements. And they're telling us it's a gas. So, now we need to figure out the formula of the compound that forms between aluminum and chlorine. Aluminum has what charge as an ion? 3+. It's in group 3A. Remember 1A, 2A, 3A, zinc, and silver. And chlorine has what charge? -1. Because the noble gases are 0, and then as you count backwards on the columns, they go -1, -2, -3. So I have my two ions with their charges. I've got a +3 here, and this one is -1, and so I'm going to need 3 of those so that when I group them together, the charge is 0. So this is going to make AlCl3. In general, ionic compounds have very high melting points, and so they're going to be solids at room temperature. I would not try to trick you with that. Balance the equation. Well, 1 aluminum, great. 3 chlorines, 2 chlorines. Odd even problem. Let's make the odd number into an even number. We'll multiply by 2. So I'll put a 2 here, and then to keep the aluminums balanced, I also need to put a 2 there. Now I need 2 times 3 is 6 chlorines, and I can see that I need 3 chlorine molecules. I don't want to do this one. I'm pretty sure you don't want to listen to it either. Let's do the last one. The reaction between gaseous hydrogen and liquid bromine. What's the formula for hydrogen? H2. And that's a gas. And what's the formula for bromine? Br2. And that's a liquid. Well, what are these guys going to do? They do not form an ionic compound, but they form a compound that dissolves in water and becomes ionic. And so we can use charges of the ions to figure out the formula. So this is HBr, which if it's dissolved in water, we call that hydrobromic acid, right? But here it's in the gas state, so it'd be called hydrogen bromide. We need 2 hydrogens and 2 bromines, so if we put a 2 in front of this guy, we're done. You can do a lot more of things like this than you think you can. You just have to take these little pieces and pull them together. Hallelujah.